Is this the breakthrough? Will we be flying to the stars soon? It could very well be, because scientists have achieved something incredible. They accidentally created a warp bubble. Find out all about it and more in today's video, and let's get right to it. Zooming through space with warp drive has probably been one of the greatest dreams of many people ever since the first episode of Star Trek, because that would likely be the only way to cover the gigantic distances in space. Just zooming off to distant exoplanets and exploring other galaxies. The problem is, all these destinations are very far away. If you were to board a spaceship right now, it would take several millennia just to reach the nearest exoplanet, for example. The crew of the USS Enterprise, on the other hand, wouldn't have these problems, and that's because of warp speed, which allows them to zoom through space. But what exactly is that? Space and time are stretched in some places and compressed in others. To simplify things, let's just imagine the Earth and the Sun. Both create a dent in space and time, and within the dent created by the Sun, the Earth orbits around it. This principle of influencing space and time could be harnessed to shorten enormous distances, and that's exactly what the warp drive from Star Trek does. In principle, space and time are compressed in the direction of travel and then expanded again at the destination. The spaceship is inside a warp bubble within which space-time is manipulated and can reach its destination within this warp bubble without moving particularly fast. This is an absolutely brilliant idea, because inside the warp bubble, the spaceship's crew would not be subjected to any g-forces, and Einstein's laws would not be violated either, since the spaceship itself isn't traveling faster than the speed of light. But until now, this was all just science fiction. Until now, a research team led by Dr. Harold White of the Limitless Space Institute has apparently succeeded in creating a real warp bubble. But how did they even manage that? Actually, the research team was experimenting with metal plates to learn more about the Casimir effect. This is an effect that occurs at the quantum level, that is on a very small scale, which causes a force to act on two parallel conductive plates in a vacuum, pushing them together. The exact origin of this force remains quite a mystery, which is why quantum physicists assume that there must be as yet unknown particles, so-called virtual particles, that cause it. During their experiments on the Casimir effect, however, they surprisingly discovered a structure at the nanoscale that exhibits negative energy properties and thus meets the requirements of the theory proposed by Mexican researcher Miguel Alcubierre. He was one of the first to scientifically substantiate the idea of a warp bubble as early as 1994, and concluded that a warp bubble would require a fuel with negative energy density, also known as exotic matter. And it's not just the negative energy that matches Miguel Alcubierre's predictions. The ring-shaped structure of the mini warp bubble does as well. Does this mean we'll soon be able to fly to the other end of the galaxy? It probably won't happen that quickly, since the discovered mini warp bubble is of course far too small to be used to propel a spacecraft. And I think this is a truly brilliant idea. Dr. White and his colleagues have developed a concept for a very small warp spacecraft that could travel from one place to another by creating its own warp bubble. This mini Enterprise would consist of a sphere with a diameter of 1 micrometer located inside a cylinder with a diameter of 4 micrometers. If this works, we'll be one step closer to creating larger warp bubbles, and I think that's pretty amazing. But isn't it possible that other civilizations in space are already more advanced than we are? Alien civilizations would be sending all kinds of signals into space, unintentionally. We do that too, by the way. Radio waves, and of course all other electromagnetic waves from Earth, travel in every direction through space. So the first thing aliens would hear from us would probably be some silly radio jingle. Radio waves from Earth haven't traveled very far yet, but if we assume that alien civilizations have existed a bit longer than we have and are sending electromagnetic waves into space, that could very well be the case, and it would mean that based purely on the distance traveled, we'd have a chance of picking up these signals. However, these signals weaken with distance, making it nearly impossible to filter out the noise beyond a few hundred light years. But there are waves in the cosmos that do not weaken and have nothing to do with light. Waves so powerful and persistent that they cause space-time itself to wobble and vibrate. Gravitational waves, they are generated by massive cosmic collisions, for example between black holes and neutron stars. When these super heavy and dense stellar remnants crash into each other and merge, they cause space-time itself to vibrate. And we can measure that. All objects with mass and velocity cause space-time to wobble. With our current measuring instruments, however, it takes very massive, heavy objects to generate gravitational waves that we can detect. I can already hear you nervously asking when the aliens come into play. If gravitational waves don't weaken weaken noticeably over long distances the way electromagnetic waves do, then we could use them to detect alien civilizations, no matter how far away they are, even at the other end of the galaxy. Alien technology that generates gravitational waves detectable by us would have to be incredibly impressive. Researchers at the University of California, Los Angeles have now calculated the size and speed of an extraterrestrial spacecraft that could potentially be detected by us in this way. They called it a rapid and slash or massive accelerating spacecraft, or RAMA craft for short. What the researchers have calculated is a bit bizarre, so hold on tight. A RAMA craft would have to have the mass of Jupiter and be capable of accelerating to 10% of the speed of light. If such a spacecraft were operating at a distance of up to 326,000 light years from Earth, we could detect it. Okay, I'll admit, that does sound a little out there, but look at it this way, such a RAMA craft wouldn't necessarily have to be a traditional spacecraft. It could also be gigantic megastructures, so-called Dyson spheres. That is, massive structures that advanced civilizations could build around entire stars to fully harness their energy. The only way to find out is to take a closer look. And it looks like the gravitational wave method is our best bet. The gravitational wave detection program is now set to be expanded and extended to other galaxies. In my view, it's definitely one of the most promising projects for finding extraterrestrial civilizations. I'd be very interested to hear your thoughts. What's our best chance of finding aliens? Feel free to share your ideas here in the comments. By the way, there was another breakthrough in warp research. One research team had created a mini warp bubble, and another group of scientists succeeded in replicating an essential effect of warp travel, the so-called restlessness effect. We've already learned what a warp drive does. Time and space are compressed in the direction of travel and then expanded again at the destination. But what exactly is the agitation effect? The agitation effect states the following: an observer accelerating uniformly in a vacuum sees, instead of the vacuum, a gas of particles such as photons, electrons, and positrons with a temperature proportional to the acceleration. Okay, that probably doesn't really explain it yet. Basically, this formula just describes what we see with the warp drive in Star Trek, a kind of quantum glow. An object, for example, a spaceship, moving quickly through the vacuum of space should emit warm radiation as a result of its acceleration. This radiation arises from quantum interactions and fluctuations in space. To put it even more simply, for anyone who was really bad at physics class, when a spaceship accelerates to warp speed, it starts to glow. But here's the problem. This agitation effect, the quantum glow, had previously only been described in purely theoretical terms. To observe this effect at the atomic level, an atom would have to be accelerated to the speed of light in less than 1/1,000,000th of a second. A research team at the University of Waterloo has now discovered a way to stimulate this agitation effect so that it can be studied directly under less extreme conditions. In other words, to create a mini warp glow. The agitation effect lies precisely at the boundary between the laws of quantum physics and general relativity. According to the laws of quantum physics, an atom would have to wait for an incoming photon to penetrate its electromagnetic field and set its electrons in motion. If we take into account the theory of relativity, classical physics, there is a way to cheat. By simply accelerating the atom, it could perceive the slightest fluctuations in the surrounding electromagnetic field as low-energy photons and thereby become excited. It was previously assumed that this effect could be neglected, but the new study shows that it is significantly more important. To demonstrate this, the researchers tickled an atom in just the right way with a powerful laser, proving that it is possible to exploit these interactions through motion to make moving atoms experience the agitation effect without requiring large accelerations. Or to put it simply, you could use a warp drive without actually having to reach warp speed. It's only a small step, but it's still a step toward warp drive. But there are also physicists who suggest that we simply reverse space-time just as one might reverse an equation. And if we could succeed in reversing space-time, then the path to the stars would be wide open to us. As far as we know, there are at least 4 dimensions in the universe, 3 spatial and 1 temporal. Together, these dimensions form space-time. An object's speed through space affects time. The faster an object goes, the slower time passes for that object. Now let's imagine a photon, a particle of light. As we know, it moves at the speed of light. This speed has such a massive effect on space-time that the time component disappears entirely. Time is thus slowed down so much that it comes to a standstill, but what if we could simply change the signs while remaining within the framework of physics? More specifically, what if we could turn 3 spatial and 1 temporal dimension into 3 temporal and only 1 spatial dimension? Sounds crazy, but that's exactly what a team of researchers at the University of Warsaw is proposing, and they call this phenomenon the speed of light, based on the number of dimensions, 1 plus 3. If we were to theoretically exceed the speed of light, perhaps the ratio of spatial to temporal dimensions would simply reverse. And I'll make it even more complicated for you because we're talking about the superluminal observer. This is a theoretical observer traveling at least apparent superluminal speed. This would work, for example, through our familiar warp drive without breaking the laws of physics. And during the warp jump, you're now looking out the window. What would you see? At that moment, you'd be taking on the perspective of the superluminal observer. In reality, however, the superluminal observer isn't actually faster than light. After all, they're sitting comfortably in their warp bubble, but they could perceive the area outside the warp bubble at superluminal speeds. What the researchers from Poland asked themselves in essence is, what does space look like to the superluminal observer? And this is where the sign reversal of the relativistic equation I just mentioned comes into play. For the superluminal observer, 3 time dimensions would suddenly open up and he would see the cosmos aging differently in all 3 dimensions. We really can't imagine this with our underdeveloped monkey brains since we're wired for 3 spatial dimensions. However, such a superluminal perspective could give humanity an immense technological boost. This is because researchers believe their theory could serve as a bridge between Einsteinian physics and quantum mechanics. They think that the rules of the theory of relativity transform into quantum physical phenomena within the 1 plus 3 framework in which the dimensions are reversed. In quantum physics, there is a specific phenomenon called superposition. This means that subatomic particles can exist in multiple states simultaneously, and astonishingly, this situation only changes when they are measured. In the superluminal world, an observer might see objects moving along multiple time paths simultaneously in accordance with the principle of superposition, and if we could harness and influence this, the entire fundamental concept of the universe would likely be open to us. We've talked a lot about how one might create bubbles within space-time, how one might invert space-time, and none of this is just a figment of the imagination, because it actually exists out there in space in the form of black holes, and potentially white holes as well. According to most astrophysicists, our universe has existed for just under 13.8 billion years. According to the prevailing view, the starting point was the Big Bang, an act of self-creation by the cosmos. For mysterious reasons, this point then began to grow and grow until today, and it's still expanding. The vast majority of galaxies are currently moving away from us. The universe arose from nothing, and before the universe, there was simply nothing. However, there are also many other hypotheses, including the idea that our universe is located inside a black hole. Today, I'd like to introduce you to a similar idea that takes a slightly different approach, one that I find very exciting, namely that our universe is the product of a white hole. But first, we need to clarify what a white hole actually is. You can think of it as the counterpart to a black hole. To put it very simply, black holes pull things in, while white holes spit things out. And if you take this idea further, every black hole could be connected to a white hole. This connection, this space-time tunnel, would then be an Einstein-Rosen bridge, or colloquially, a wormhole. But this is all just theory, since practical proof of the existence of white holes has yet to be found. However, they are possible within the framework of Albert Einstein's famous field equations, and another argument for the existence of white holes is the so-called information paradox. If something disappears behind the event horizon of a black hole and ultimately becomes part of the singularity, the information contained in that swallowed object is lost. However, there is a principle of quantum physics that states that information cannot be lost. Yet in a black hole, this seems to be exactly what happens. A paradox. The solution to this information paradox could, that's right, be white holes. Perhaps the information isn't lost at all, but rather travels through this wormhole into a new universe. There is a singularity at the center of both black holes and white holes, and our universe too began with a singularity. So could our universe have been born from a white hole? When it comes to singularities, the principles of classical physics break down somewhat, since an infinitely small, infinitely dense point is not really possible or describable. Some quantum theories therefore quantify spacetime and postulate a quantum theory of gravity. They conclude that classical physics' view of black holes is incomplete. According to the theory of loop quantum gravity, the fundamental building blocks of space-time take the form of extremely small loops known as quantum loops, and these loops have a finite and therefore describable size, meaning they would be consistent with physics. According to loop quantum gravity, the mass of an object cannot be compressed all the way to the point of singularity. Instead, before reaching the point of singularity, the star would undergo a quantum leap, at which point the black hole would transform into a white hole. Our universe may have come into existence when somewhere else in a parent universe, a very massive object collapsed and a white hole was created through a quantum leap. The point at which time ends inside a black hole is linked to the point at which time begins in a new universe during the Big Bang. Okay, so far we've talked about traveling to distant galaxies and even other universes. However, researchers at Leiden University in the Netherlands wanted to figure out how to better understand the movement and propulsion mechanisms of very, very small objects or biological entities, specifically bacteria, sperm, or blood cells, so they figured it would make sense to create objects that could operate at exactly the same scale as these cells, and then they simply created an object using a 3D printer, just 5 micrometers in size. That's slightly larger than a blood cell. Well, and it wasn't just any off-the-shelf 3D printer either, and that's exactly what they needed because they wanted to find out how such a tiny object behaves inside the human body. The significance of this is immensely important in my view. The point is that, in the future, we'll be able to use such artificial microswimmers in medicine. There's an idea that so-called nanorobots might one day be able to transport medications through the body. Here's a small example. What do you do when you have a headache? You probably take a painkiller. It affects your entire body and doesn't target the specific area where you're feeling pain. As a result, you have to take more of the active ingredient than you actually need. A nanorobot could deliver the painkiller directly to the site, and the pain would be treated locally, right where it hurts. That would be much more efficient and put less strain on the body. But think even further, just imagine all the possibilities this would open up. Someday, and there are already research papers on this, researchers could have such nanorobots swim through our bodies, traveling through our bloodstream to perform cellular repairs from the inside. This could help treat diseases like Alzheimer's by specifically repairing damaged areas of the brain. One field that relies heavily on these nanorobots, these artificial microswimmers, is cryonics. This technology could be used to freeze people for space travel, and the nanorobots could ensure that these people could simply be thawed out hundreds of years later without suffering any long-term damage. This would make us ideally prepared for long space journeys. I hope you're all warp experts by now, guys. As soon as there's any new development in warp drive research, I'll keep you updated right away. But of course, that's only possible if you follow my channel. Subscribing is absolutely free. You'll never miss another galactic video, and you'll be helping me out immensely. And if you're looking for even more cosmic mind blows, I've got something else for you. According to a new study, traveling through space could become even more difficult than it already is, because the cosmos might be nearly twice as old as previously thought, a whopping 26.7 billion years. That would, of course, mean that everything we can see in the night sky would be much further in the past, and we'd have to completely rethink our understanding of the Big Bang. You can find out everything about this crazy story in the video below. As always, there's another topic related to science and space in the bottom right corner. Other than that, I'd say, see you in the next video. Take care, everyone, and live long and in peace.